So hello students, today we are going to learn part 7 of chapter number 20, that is exponents and powers. Okay, in this part we are going to learn how to make use of exponents to express large numbers in standard form. Okay, so without wasting our time, let us start it. Okay, now before learning it, just look at some rule. Okay, in this period we are going to deal with the decimal numbers. Okay, we are going to change the position of decimal. So what happens to the other number, that is power of 10, when we are changing the position of decimal? So one rule is there: when the decimal moves to right, power of 10 decreases, and when the decimal moves to left, power of 10 it increases. Okay, so in very simple manner I have written it here. Now this one is our suppose decimal. If it moves to left, then the power of 10 it goes on increasing, and when the decimal it moves to right, the power of 10 it goes on decreasing. Okay, so for a minute have a look at this one. Now let us solve some examples based on this one. Okay, so here it is given that express the following numbers in standard form. Okay, now what is the standard form? First let us clear about the standard form. Okay, standard form means, suppose if we have a number, I'm writing it here. I have a number 126. Okay, point 5. Okay, standard form means now this decimal is present over here, so we want to bring it before first two numbers. Okay, and the condition is that this number should not be 0. Okay, so where must be the decimal? Between the first two digits. Condition is that the first digit it should not be 0, any number other than 0. This is standard form. Okay, so for example, now when I move this decimal to left, there will be some change in the power of 10 that we will see in example. Okay, now here we have 9368. Okay, so same number I have written it here. What number do we have? We have 9. So here we have 9368. Now what is the condition? We want to bring this. If in this number nowhere decimal is there, it means that it is present at the end of the number. Okay, so if it is present at the end of the number, if you're not writing it, then also it will work. Okay, so right now the decimal is present over here. Now what is the condition to make it in standard form? We want to bring it 1, 2, 3 digit to the left. Okay, we have learned that when we are bringing decimal to the left, there is some change in this number. What change is seen? So now what we will do, if the decimal is moving to the left, okay, then we have to write multiplied by how many digits we are moving to the left, that much 0 should be there in front of 1. Okay, now we have 9.368 into 1000. Now how to write this 1000 in terms of power of 10? So that we will write it as 1000 means it can be written as 10 raised to 3. So what is our answer? 9.368 into 10 raised to 3. Is that clear? So now I have written it here directly. So what is the answer? Decimal was present over here. If it moves 3 digits to the left, then we have to multiply it by 10 to the power 3. Okay, the power of 10 it goes on increasing. Okay, let us consider one more example. Now here we have 170000, that is 4 zeros are there. Now in this number nowhere decimal is given, so where the decimal must be present? It should be present over here. Sorry. Now if you want to write it in standard form, so what is the condition? Decimal should be between first two digits from left side. Okay, and such a condition that the first digit should not be 0. Now decimal is present here. To bring it here, we have to move 1, 2, 3, 4, 5 digits to the left. When we are moving 5 digits to the left, so what we have to do? We have to write it 10 raised to 5. Okay, in this way. So In front of 1, how many zeros must be there? 1, 2, 3, 4, 5. Okay, now what we have to do, this can be written as 10 raised to 5. Okay, so what is the answer? So 1,70,000 can be represented as 1.7 into 10 raised to 5. What is the need of writing these numbers in this form? You can see that if suppose more zeros are there, then it will be a little bit difficult work to write. Okay, so better is that this one is the simple form of this number. Okay, so I have written here 17000. So what we will do, decimal was present over here, so 1 2 3 4 5 digits we came to the left, so power is 10 raised to 5. Okay, now for this example we are going to solve it directly. Now nowhere decimal is there means decimal is present over here. We want to write it in standard form, so where the decimal should come, so it should come between 8 and 3. So how many digits we have to move to left? So 1 2 3 4 5 6 7. Okay, so what must be our answer? So it will be 8.365 into 10 raised to 7. Now remember why we are not considering this number. Once we are giving these decimals, then at the end number of zeros doesn't matter. Is it clear? So, and in detail form I have written it here. You can see this one also. Okay, now this one, in this one what we have done, we were moving decimal to the left. Okay, so what effect was seen on power of 10? It is going on increasing. The number of digits you move to left, the power of 10, it goes on increasing. Okay, and the same rule we have seen, that when the decimal moves to left, power increases. Now let us see what happens when the decimal moves to right. Okay, so here we have next example. Now it is given that write the following numbers in usual form. Okay, so now this one 3.95 into 10 raised to 6. Okay, now usual form means we have to move this decimal. Okay, at the end there should be no decimal in the number. Decimal must be present at the end. Now here it is given 10 raised to 6. What does it mean? If you want to remove this 10 raised to 6, we have to move this decimal 6 digit to the right. Okay, now this 3.95, it can be written as 3.95. Now 1 2 3 4 number of zeros you can give as per your requirement. Okay, now 10 raised to 6 means we have to move this decimal 6 digits to the right. So 1 2 3 4 5 6. So our answer will be that equals to 395,123,4. Okay, now the decimal will be present over here. Okay, so here what we have done, we have decreased the power of 10. Okay, now as we are decreasing the power of 10, the decimal is moving to the right. Okay, and same rule we have seen before. Okay, so our answer is same, that is 39540, 39540. Now let us consider next example. Now here it is given 8.239 into 10 raised to 7. This one is a standard form. We want to write it in usual form. For writing it usual form, we want to remove this decimal. It should be present at the end of the number. Okay, so 10 raised to 7 means this decimal will move 7 digits to the right. Okay, now we are having only 4 digits. Okay, so let us write that 4 digit first. Okay, now remaining digits, so sorry, we are having only 3 digits now after decimal. We want to move it 7 digits, so 4 digits are short, so we'll write there 1 2 3 4. Okay, now when you're writing removing this decimal, okay, let me write one more thing over here. Into it is 10 raised to 6, here also it is 10 raised to 6, and finally it becomes this one. Okay, so here also you have to write into 10 raised to 7 into 10 raised to 7, because up till now it is in standard form only, but now we want to remove this 10 raised to 7 so that it will become usual form. So how many digits we have to move to the right? 7 digits. So 1 2 3 4 5 6 7. Okay, so our answer will be 8 2 3 9 1 2 3 4. Okay, now where is the decimal? So decimal is present at the end of the number. Let us consider one more example. Okay, so our next example is 3.0007. Now remember these zeros, after these zeros a digit is there, means we have to consider this one. Okay, now 10 raised to 9 means the decimal should be present at the end of the number, and how many digits we have to move to right? 9 digits we have to move to your right. Okay, so let us write that number. Okay, so we have 3.007 into 10 raised to 9, which can be written as 3.007. Now how many zeros? So 1 2 3 4 5. Okay, now count 1 2 3 4 5 6 7 8. So we need to write here one more 0. Okay, now when you are moving this decimal to the right, what will happen? The power of this 10, it goes on decreasing. Okay, so it will become equals to 3007, then 1 2 3 4 5 6 zeros. Okay, so now this one is what? This one is the usual form of this number. Okay, so I think this much is enough for today. Okay, hope you all must have understood up till here. Thank you, have a nice day.